Hi everyone, welcome back to another video. In this session we're going to be covering partial differential equations. We automatically are asked to find the partial differential equation because we can see there is a curly letter D instead of the normal straight letter D. So automatically we want to recognize this is a partial differential question. Now it's asking the same thing, let's find the derivative of the function f with respect to x, and it's asking to find the partial differential of f with respect to y, where we've got f of x and y is equal to this question here. So we've got 4x cubed plus 3xy minus y squared. Now, the partial differential equation is pretty much the same like the normal differential equation, but where we differentiate with respect to a certain letter, we hold the other letters constant. So let's look at this example. What this means is if we take the partial differential equation with respect to x, what we do, we hold the y constant. So I'm going to say when we are looking at x, y is equal to a constant. So just think about it as another number or an integer, and it'll be looked exactly like this. So it'll be, we differentiate with respect to x, the 4x cubed. We take each part as normal, plus the differentiation of 3xy minus the differentiation of y squared. Now, just like normal, if we are asked to differentiate 4x cubed, we do the same thing. We bring the power down, we multiply and minus 1 from the power. So that's going to equal 12x squared. Now, in this case, remember, we are differentiate with respect to x, and all the other letters, no matter what, is a constant. So if we had, for example, just 3x, so for example, if we were just asked to differentiate y is equal to 3x, it's the same thing. dy over dx equals 3, because that is a constant that has a power of 1. We minus 1 from the power, which is 0, and x to 0 is just 1. Whereas now, if we have 3xy, remember, y is just a constant. Think of it as another number. So we can hold the 3 and the y on the outside. So it's going to look something like 3y, and then we just do the differential respect to x. And x just becomes, this part just becomes 1, and that's multiplied by 3y. So that's just 3y. Now, same thing here. Now, as we differentiate with respect to x, there is no x term, and y is a constant. So just imagine this was, for example, y is 5, so 5 squared is just 25. Differentiation of 25 with respect to x is just 0. Likewise, if it was 100, 1000, 1, 5, 10, it could be anything, that would just go to 0. So that's just going to be, that's your final answer, 12x squared plus 3y. Now, if we take it, the differentiation with respect to y, so we look at df over dy is equal to the same steps. So we've got to look at 4x cubed with respect to y. We take the differentiation of 3xy and the minus y squared. So we've got no y term in the 4x cubed, so remember, that goes to 0. Here in this case, we treat x as the constant. Why? Because we are differentiating with respect to y. All other letters are constant, so it could be the letter I, J, K, P, Q, anything. Those letters will be constant. So, therefore we can say that's equal to 0. Then we take the differentiation of 3xy. Remember, 3 is a constant, it's just an integer. X is a constant, so we can take those on the outside. And then y, differentiation of y with respect to itself is just 1. So we've got 3x minus, and then the differentiation of y squared with respect to y is just 2y. So that's the answer with respect to y. Let's look at another example. So here we have another question. We've got fx of y is equal to sine x plus cos y. Now again, we're asked to find the differentiation, the partial differentiation with respect to x and y. So again, what we say is df of dx, so partial differentiation is in this case, if we look at sine x, so there's just differentiation as normal of x, which is cos x, and now cos y, as there is no x term, everything else is just treated as a constant, and a constant, differentiation of a constant is just 0, so that goes to 0. Now if we look at the partial differentiation with respect to y, it's going to be the opposite. That sine x will go to 0, whereas y, cos y, we can differentiate that with respect to y, and that's going to equal minus sine y. So that was a little easy one. Let's step it up a bit. So in this example, we've got three variables x, y, z, and we've got the fractional term sine x, y, z all over x, y, z. Here we automatically know this is a quotient rule because there's a fractional term, so we're going to have to use the quotient rule. So if you don't know what the quotient rule, check out my previous video. I've just uploaded a video on how to use the quotient rule. So let's take the first derivative, df over dx. What we first need to do is categorize u and v. We're going to let the numerator equal u, and we're going to let the denominator equal v. So therefore we're going to say is u is equal to sine x, y, z. Therefore the partial diff of u with respect to x is the exact same. So yz become the constants. We bring the yz outside because it's a constant. Yz, and we've got cos x, y, z. So we say v is equal to x, y, z. Again, we take the partial diff, dv over dx. Y and z are constants, and differentiation of x is just 1, so we got y, z. Again, I cross multiply, so I start with bottom left, top right, and then in this case we've got a quotient, so we minus the other cross multiply all over v squared. So that's going to be the partial diff of f with respect to x is equal to x, y, z, all multiplied by y, z, cos x, y, z, and minus the remaining cross multiply, which is yz sine x, y, z, all divided by your v squared, which is your x, y, z squared. Now we can simplify this, so we've got x, y squared, z squared, x, y squared, z squared, cos x, y, z, minus y, z sine x, y, z, all over, that should be in brackets, so that's x squared, y squared, z squared. Now what we realise is we've got common variables of a y and a z, so we've got yz at the numerator on the left hand side, and we've got a yz on the right hand side and in the denominator. So what we can do is just divide by yz. Therefore the partial diff is equal to x, y, z, cos x, y, z, minus sine x, y, z, all over x squared, y, z. So that's your answer. Now we can repeat this for y and z. So we're going to do the same thing. We've understood what a u and a v is, so we're going to do the same thing, partial diff, but we're going to do respect to y in this case. So that's the partial diff of f with respect to y. So u again is equal to sine x, y, z. The partial diff of u with respect to y is equal to x, z, cos x, y, z. Remember, x and z, all other letters are held as a constant. So we've got v is equal to x, y, z. The partial diff, dv over dy. X and z are constants, which is just xz, and y is equal to 1. Therefore, df over dy, the partial diff, is equal to the same thing, so we cross multiply. But what we can do, as it's the same steps as before, let's try go one step ahead. So we've got x squared, y, z squared, so we cross multiply bottom left with the top right, that's with cos x, y, z, minus xz times sine x, y, z, all over our v squared, which we know as x squared, y squared, z squared. In this case, we've got an x squared term, a z squared term here on the left hand side of the numerator. Likewise, we've got an xz of the numerator on the right hand side and in the bottom, so we can divide through as they are all in common. So let's divide by xz. So that's going to equal x, y, z, cos x, y, z, all minus sine x, y, z, and that's going to be x, y squared z. So finally, we've got the partial diff of f with respect to z. So lastly, we've got the partial diff of f with respect to z. Again, we state out our u and v, which is sine x, y, z. Our z, in this case, we are differentiating with respect to z. So x and y are constants, so that's going to be x, y, cos x, y, z. V is our x, y, z. Therefore, we can say differentiation of v with respect to z is just x, y, as z goes to 1. Therefore, df over dz is equal to the cross multiply. So again, that's going to be x squared, y squared, z, cos x, y, z, minus x, y, sine x, y, z, all over x squared, y squared, z squared. What we've got in common is x and y throughout the numerator and denominator, so we can divide by xy. Therefore, that leaves us with x, y, z, cos x, y, z, minus sine x, y, z, all over x, y, z squared. So hopefully that's made sense. If you've enjoyed the video, please do leave a like, please do subscribe, as that will really help me out, and I'll catch you guys in the next video. Take care.